So a box is being pulled across the ground with a force that has both a y component and an x component. So if you look at just the y direction forces, you realize that it's Fn, which is going up, minus mg, which is pulling it down, plus F sine theta, because it's pulling at that angle, which is making the box go up slightly. It's sine theta because if you put the theta in, which I forgot to do, you realize that this y component is the sine theta. So F, the normal force, is equal to gravity minus F sine theta. So F cosine theta, which is the force that's pulling the block along, has to be greater than the friction. It has to overcome this friction to be able to move. Friction is static coefficient times Fn, which we found before. So if you simplify this out, which I didn't, in the test, you figure out that F has to be greater than mu s mg divided by cosine theta plus the coefficient of friction times sine theta, because I did algebra in the previous step and distributed it out and made sure that both F components were on the side, and I took out the things. For B, I put, for some reason, my normal force was F sine theta minus mg, but that doesn't make sense as I explained up here what the normal force is. So when you solve for A, you get the acceleration of the block is equal to F cosine theta minus the friction force, because this is positive and the friction force is opposing its forward movement. So A is equal to F cosine theta minus the coefficient times the normal force, which is mg, minus F sine theta, all over m.